Okay, for section 11.1 we are getting into our three-dimensional chapter and going to look at three problems to help you out today. One's going to ask you to find the center and the radius for the following sphere. Second one, basically same problem, find the center and radius for the following sphere. Both of them going to have to recognize they're not in standard form, so we have to get them in standard form. And then the third one is to find the xz trace of that sphere. Alright, so I'm not doing any of them that are asking you to find the distance between 2 points in 3 dimensions or the midpoint between 2 points in 3 dimensions. The formula is very straightforward with that. If you do have trouble, you're always welcome to ask, like always. But let's take a look at the first one. Find the center and the radius for the sphere. Now, I can see it's a sphere because I've got 3 variables being squared. And I know it's not in standard form because I see I've got x squared and I've got a singular x term. I've got a y squared term and a regular y term. Now the z part of this, the z part is actually in standard form because there's no z term here. So I need to complete the square with both the x's and the y's. And so I'm going to rewrite this equation and I'm going to put the x terms next to each other. That's supposed to be a minus sign, minus 6x. And I'm going to put the y terms next to each other, y squared and 4y. And if I had more than one z term, I would put those together too. And then I'm going to move the constant over to the right side, so I'll subtract it. And basically what I'm going to do is I'm going to complete the square and do it twice, just like you did in chapter 10, the first half. So I've got a 1 in front of the x squared, so I can now take half of the b value, which would be -3, square it, which would be 9, and add it to both sides. Alright, now do the same thing for the y's. You've got a 1 in front of the y squared term, so divide the b value by 2, which would give you 2, square it, which gives you 4, add it to both sides. And I don't need to do anything to the z squared term because there's no regular z term. Now, if I've done that step correctly, the b divided by 2 squared, this should factor into a perfect square, and it does. Factors into x minus 3 squared. This factors into y plus 2 squared. And of course, the z squared, I didn't have to do anything to it. And adding those together, I get 4, and now I have it in standard form. So finding the center, set each parenthesis equal to 0 would give me +3. Would give me a -2, and it would give me 0. And my radius is the square root of this number, so it is 2. So overall, if you were comfortable with what we did in chapter 10, the first half of chapter 10, this is very similar. You just have an extra variable in there is all. So this problem, same thing. I look at the x squareds and say there's an x squared, there's an x, so I've got to complete the square. Y squared, there's a y. And then I notice that I do have an extra z, so I'm going to have to complete the square with all 3 of these things. So again, I'm going to rearrange the order of all of them and say it's 4x squared minus 4x plus 4y squared minus 32y plus 4z squared plus 8z, and subtracting over the 33, it'll give me a -33. And then if I look at all of these, I'm supposed to have a 1 in front of the x squared, so I'm going to factor out the 4 or whatever number is in front of it, so that I end up with a 1 in front of the x squared. Make sure you factor it out of both numbers. Do the same thing for the y squared, so that it's 1y squared. Make sure that you again factor out the 4. And do the same thing for the z squareds. Now, it's not the only way of doing it. You could divide everything by 4, including this, though. Don't forget this. And that's going to give you a fraction. A lot of you don't like dealing with fractions, so this is one way to kind of get around them for now. It will work, and I'll show you that maybe in a second. Alright, now I'm to the point where I'm going to do the b value divided by 2 thing. So, take your b value, which in this case is -1 divided by 2, so -1/2, and square it. And squaring a fraction, square both the numerator and denominator, so 1 over 2 squared would be 1 over 4. Now where you have to be careful with this is, I'm not adding 1/4 technically, there's a 4 in front of that parenthesis. Technically, if you distribute, I'm adding 1 to both sides. Alright, do the same thing with your y squared terms. Divide the b value by 2 gives you -4, square it would give you 16. Technically, I'm adding 64 to both sides. And do the same thing with your z squared terms. Half of your b value here gives you 1. Square it would give you 1. But you are technically adding 4 to both sides. And now, these should factor into perfect squares. These two are probably easy to see it. This one can be messy because it's not going to work out nice in terms of you're going to have fractions. So always the rule of thumb, think of it this one. I'm going to jump to the y squared terms. This one we can probably see factors into y minus 4 quantity squared. It's always half of the b value. Always. Look at the z squared term. It would be positive 1, and it just so happens to be half of the b value. So that's a kind of a rule of thumb you can use if you get something that's not so easy to see. So this is going to be negative 1/2. Make sure you pay attention to the sign. Squared. Equals, this looks like that's 69, negative 33. Looks like that's going to give me 36. And now is when I say, okay, now let's go ahead and divide everything by 4. And that's going to give me x minus 1/2 quantity squared plus y minus 4 quantity squared plus z plus 1 quantity squared is equal to 9. And now I've gotten rid of those 4s. And that's what I want to do, because standard form I don't want to have any numbers in front. And now I can easily see my center and my radius. Center is going to be positive 1/2 for the x value, positive 4 for the y value, negative 1 for the z value. The radius is going to be the square root of that number, so it's 3. Now, like I had said before, if you wanted to divide everything by 4, it would have been fine. You just have to make sure that you divide that by 4. You would have basically been to this step right here. And then when you take half of the b value, square it, add it to both sides, you would have been adding 1/4, which would have given you negative 32/4, which would have given you negative 8, and then of course those would have given you nice numbers. So eventually it would have worked out the same. So it's however you want to do it. This is the way I like doing it, factoring out the 4, but if you think dividing by 4 is easier, go for it. Plus, you might want to look at these numbers. If they're all evenly divisible by 4, then yeah, go for it. It probably would be easier to do it that way, but either way is fine. Alright, we talked about this in class, and conceptually it's a little hard to get, but the idea is simple enough, I hope. You have a sphere. Here's our sphere. And imagine if you took that sphere, imagine if you had a solid ball, maybe a foam ball, and you took and you cut off a section of it, assuming that you make your cut straight and clean. If you took that section and then turned it and looked at it, you would be looking at a circle. That's what they're referring to when they say the trace of a sphere. Now, they're making this easier because if you cut this at an angle, you're going to have a trace that's going to have a really weird equation, or be a little harder to find. We are always going to have our traces either cut on the x-axis, the y-axis, the z-axis, one of those axes. So they're asking us to find the xz trace, which, to make this simpler, what you need to do is this. Understand that when you do find a trace, you are looking for a circle. And then the other thing is, notice what variable is missing? It's y. Well, basically all you do is you set y equal to 0, because on the xz plane, all of the y values equal 0. That means y is 0, you simply plug 0 in for y and then simplify what you're left with. And eventually what you're left with is going to be a circle, because that term will be gone. And you'd have 2 squared terms. So the idea is, the problem to solve it is actually simple enough. You just have to understand what they're asking you. So whatever variable is missing, plug 0 in for that variable and go from there. So I'm going to have x minus 3 quantity squared plus y now becomes 0 minus 4 quantity squared plus z minus 5 quantity squared is equal to 32. I know that this is going to give me 16, and I'm just going to subtract it over to the other side. So I'm left with x minus 3 quantity squared plus z minus 5 quantity squared is equal to, looks like 16. And there's my equation of my circle, which is the trace. So that's the equation. If I could take that sphere, cut it on the xz trace, and then take a look at the circle, this is the equation of the circle I'd be looking at. If you do have questions, like always, you're always welcome to come in and ask me for help if you need it. There is your homework help for 11.1.